Hi, my name is Sophia Dominguez, and I'm the moderator today for the panel on 5G, AI, and machine learning, how communication drives opportunities. As I mentioned before, my name is Sophia. I'm the head of camera platform partnerships at Snapchat. I'm going to give you a quick background about myself before we do introductions to the other speakers. So I've been passionate about augmented reality, virtual reality since I was 13. I read a book called Feed by M.T. Anderson, which talked about a future world where we had a chip in our bodies and everything was AR and VR, but we didn't call it that. And that's when I knew I needed to work in this industry. I was the first and only person to travel around the world with Google Glass and document how people reacted to the first AR headset. And then I started my last company, which is called Surf, which is the Giphy of 3D. We recently sold the company at the beginning of this year before I joined Snapchat. At Snap, we're really excited about 5G as it will especially allow neural networks and larger assets to fit within a lens. And especially with our recent launch of SnapML, which allows you to add your own machine learning models onto lenses. And with that, I'm going to introduce Vanitha.
Hi, I'm Vanitha Kumar, a VP of Engineering at Qualcomm. I've been with Qualcomm for the last 23 years, and I've been in the space of wireless technologies pretty much from the time I graduated, and even way back in college when I focused on cellular technologies as my research area. Right now, I lead a global team that focuses on all aspects of cellular technologies from 3G to 5G. And for the last few years, my focus, of course, has been on building the software for our 5G group, and which revolves around the 5G stack and commercialization on all the Qualcomm chipsets. We are very excited about the possibilities that 5G is going to bring in terms of how it is going to transform the world. Thank you.
Great. And now we'll be introducing you to Sanyogita.
Hi, everyone. Excited to be here. My name is Sanyogita Shamsundar. I lead the technology innovation team at Verizon. I'm the vice president there. I have been with Verizon for about 12 years. Been in various roles, starting with 4G devices, and then I did a lot of network level engineering and design and technology strategy. More recently, I've been focusing on 5G, especially from a product viewpoint, and where can we bring in innovators from outside and combine various technologies such as machine learning, data analysis, AR, VR, that essentially use 5G and the capabilities of 5G to create new services and products for our customers, whether it be consumer or enterprise. I've been in this industry for a long time, for 20 plus years. I started off as an engineer, have a PhD in electrical engineering, and then moved on to a more strategy type of a role, leading mostly technology groups. Let me pass it on to Sophia again.
Awesome. Thank you so much. And now I'll introduce you to Elena.
Thank you. Hello, everyone. I'm an AI researcher since many years back. I did my master's in AI, and that was really a really long time ago. And since then, I had various positions at Ericsson. I'm currently heading up AI research team, global team at Ericsson, and I'm also an adjunct professor at Royal Institute of Technology in Stockholm, Sweden. Where we're making sure that long-term research goes together with more applied research and actually comes into the products and services. And of course, we're applying AI, many different parts of AI, such as machine learning, machine reasoning, into different technologies, into 5G products and services, for example. Thank you.
Great, thank you. And last but definitely not least, we'll introduce Shilpa.
Thank you, everyone. I'm Shilpa Talwar. I work for Intel Labs in Santa Clara, California. And I've been at Intel for 15 years. And prior to that, I worked in San Francisco Bay Area in wireless communications for an additional 10 years. So I've been working in wireless for about 25 years now. And at Intel, I lead a research team focused on next generation wireless technologies, starting from 4G to 5G. And now we're looking at what comes beyond. And we see that machine learning and AI are very important tools that can help optimize the performance of wireless networks in the future. And we are actively developing solutions to make the networks more efficient. I'm also actually currently running a program with NSF. We're jointly funding 20 plus universities in the US on this topic of machine learning and wireless. And I'm really excited about this role and look forward to talking to you more about this project.
Great, thank you. And with that, before we dive into 5G with these amazing technical women, we'll just be giving a really high-level overview of 5G to just kind of set the basis of what we'll be talking about today. So first, we'll start with a little bit of history. With 1G, you can think about it, it gave us sound. A lot of you in the audience are likely too young to remember this. I mean, for myself specifically, I wasn't really born yet when 1G was launched. But that enabled people to actually call remotely, through a cell phone. With the introduction of 2G, that was in the 1990s, then we got text messaging. Some of you may remember texting with T9. Obviously, that's evolved ever since, but at the time it was huge to be able to text people asynchronously. Then 3G came along in the early 2000s, and that gave us mobile web. And so what that really means is, we were able to actually load a web page. Now, if we were to use 3G today, we'd probably be very frustrated by the speed, but at the time it was revolutionary. And then 4G, which launched around 2009, it made everything about 10 times faster than 3G. And what that allowed was for people to actually upload photos and videos. And so with that, came products like Instagram and eventually led to products like Snapchat. And so when we look to 5G, we really look at it as a, sort of 10x network, right? Where it'll virtually connect everything and everyone, everything from IoT to virtual reality, augmented reality, self-driving cars, robots, video, drone applications, and everything else. And just in the most, simplistic way, 5G is crazy, crazy fast. So 4G maxes out at around 2 gigabytes per second, where 5G is about 10x that, which is about 20 gigabytes per second. And so 5G will enable us to connect in much more real-time ways with 1 millisecond of lag. And then I would really love to hear from the women on this panel on the more technical details, as that's their specific area of focus within their industries. And so with that, I'll turn it over to Vanitha.
Thank you, Sophia. I think that was a wonderful introduction of how we got to 5G and what 5G brings to the table. So just like Sophia explained, if you can think about 4G as the technology that brought mobile broadband to our hands, right? It was the way of instantly communicating people, like that really brought us the age of where people could communicate to anyone and anything. If you extend that concept, basically the way we look at 5G as something that is going to enable everything around us to communicate with everything else. So that is basically the communication of the world around us, making it more efficient for us and more intelligent for our own good. So this picture here, it's one of my favorite pictures that depicts our vision for 5G. I think it really does pave the way for this invention age. So if you look at this picture, we are actually talking about, whole lot of distributed intelligence around us. We are talking about smart cars, smart cities, a very, very high speed mobile broadband, a whole lot of wearables, healthcare monitoring devices. And if you look at all these devices, they all have very different use cases. Some of them need, very high battery life. Some of those need very high, very low latency. Some of these need very high bandwidth. And these kind of highly different, things that need different quality of service, different, different needs in terms of the dimensions of connectivity, bandwidth, and latency. How do they all coexist together on the same air interface, right? And that is what 5G is actually bringing to the table. And that's where we need the machine learning and the AI part of it to make these networks a lot more intelligent, so that they can in turn kind of feed into these many different applications which are actually powered by AI and ML, and hopefully we'll explore a lot more of this concept in our panel. On to you, Sophia.
Awesome. Yeah. Great. Now I'll pass it to Sanyogita.
Yeah, so this picture that I have here is a little bit busy, but think about today's cloud, right? Today's cloud, we take when we have applications that use the cloud, all the data that a lot of the data that you have either gets processed locally, let's say in a phone, and then like maybe a fingerprint identification. And then some parts of the data go into the cloud for further storage and processing and future use and, training the models and so on and so forth, right? So what 5G enables is basically that instead of having a central cloud that does all types of cloud processing, that you can do processing on the edge, as we call it, a distributed cloud. And so the architecture of a 5G network, in addition to the bandwidth that both Vanita and Sophia talked about, is also one of the other architecture. The other feature is that it allows for a distributed architecture where you can process the data on the edge. And what does that mean? Well, that means that you can have the power of the cloud in the palm of your hand, not just connectivity, but the intelligence, the data analysis, and the learning capability that the cloud provides is available readily at the device in the simplest of cases when you talk about a consumer type of an application. When you talk about a business application, what that means is that you can take very cheap sensors, let's say a camera, which has probably very little processing or no processing, a streaming camera, for example, that is today you use it for security applications. You can take that, take the video streams, take it to the edge of the network in a cloud location, and process that video for various different to extract various different forms of data out of it, right? Whether it be you use it for security, or today you can use it to make sure social distancing is practiced in a retail scenario, and so on and so forth. So two of the most important things to remember about 5G is that it offers large bandwidth, and it also offers lower latency, as well as you can then there are other applications where you can connect millions of devices and so on and so forth that will come in the future. But the immediate two features are these two features. We can talk more about the applications a little later on, but let me hand it back to Sophia to introduce Elena.
Thank you. Yes, and now we'll hear from Elena.
Thank you so much. And then I'm going to show you another busy slide. I'm not sure which one is the busiest, the previous one or mine. But in my slide, I would like to talk about the zero-touch aspects of the network. So we are talking about the 5G network. It's so extremely complex. And this is why we are actually forced to use AI and machine learning. That's very important because it's in such a complex system. It's not possible to manage it in a manual way. We need to optimize it through AI, of course. And we have a vision of zero-touch network. There is a vision of cognitive network, self-healing network, self-optimizing network, and a network where different industries with different requirements will be able to pose higher-level intent requirements on the network, and then the network would self-optimize. And that's a vision. So the vision of zero-touch network is actually that there is no need of human involvement, even though sometimes we would like to have persons human in the loop, but it shouldn't be a must for the future. So this is a kind of high-level view of how I envision that the fully optimized network would work. And that's an important thing here is the interplay of machine learning and machine reasoning, where different network elements are obviously feeding the data into some kind of AI engine, and machine learning taking care of it and building different machine learning models with different use cases. I'm actually guiding you through the slide from the left-hand side here. So we are coming to the machine learning part of the slide, and then we have different use cases. For example, prediction of KPI degradation in the system, or antenna tilt, or so on. And then after that, all these insights are stored in a central knowledge base, which is logically centralized and in practice, of course, distributed. And through machine reasoning, it picks the best solution to a possible problem that can arise potentially in the future. So we want to prevent it. And then through machine reasoning, we are picking the optimal action. And there are different ways, of course, to have a human in the loop in the system. And it's a closed loop where the machine learning algorithms are improving actually thanks to the machine reasoning part of it. Thank you.
Now we'll hear from Shilpa.
All right, so this slide basically summarizes what my co-panelists have discussed before. 5G marks a moment where multiple key technology trends are coming together. The 5G network is being transformed. The network is becoming more software-defined, programmable, flexible, in order to meet the demands of different kinds of services and different kinds of devices, such as robots and drones, that would connect to the network. There is the rise of machine learning and AI that's happening in industry, and wireless networks will take advantage of that. And so will the devices that generate lots of data. And all this data from sensors and IoT devices needs to be analyzed, interpreted, and we can learn from that data to enable new services. And then with this vast amount of data, you don't want to necessarily send it to the cloud because you're sending lots of data. It can incur high latency. So there's the emergence of edge computing, which sits closer to the radio access network to enable fast and real-time services. So at Intel, we see 5G as the convergence of computing and communications. And with 5G, it enables the device and the edge to become one single compute entity where the data and intelligence can reside in each of these entities to enable really complex and interesting services in the future. And I think that this new paradigm of compute and communication will enable many new applications and new business opportunities for us. Thank you.
Great. So now we'll move into questions. Each of you kind of addressed this, but I want to ask a little bit more directly. So with the evolution of AI and machine learning, the core technologies that have been happening for a while, what creates this symbiosis into 5G now?
So I can start. So if we, we talked a lot about, the three dimensions of 5G, right? The compute power, the connectivity power, and the low latency. And if you look at it, like the compute and the connectivity aspects are something that, definitely the AI kind of feeds on, right? The AI is basically feeds on data, lots and lots of data, and more importantly, the more real time, the better, because there are a lot more enhanced algorithms that are actually possible. So this whole concept of bringing the AI all the way from the cloud, to make it somewhat more distributed, kind of down to the cloud, that is somewhat possible to some extent because of the connectivity that is offered by the 5G, right? You have made the device, there is a computing power on the device now so much higher, and now the device is capable of sending a lot of data, all near real time to these points on the edge, which makes so many more use cases possible, that otherwise would have been kind of, hard to do. Like, for example, if you think about like real-time translation on your phone, now think about the same real-time translation, I'm talking about language translation in a video conference call. Now that requires the intelligence to be distributed and lots of data to be going back and forth. And that is something that is, easily powered by 5G. But if you go to the reverse side, right, the 5G network, like I said, it's really built for all kinds of ubiquitous services, right? You're really trying to build for, something, that needs like a very long battery life, to something that needs very low latency and very high precision, and to something that needs lots and lots of data. So if a network is so flexible, then you need a lot of intelligence to make smart real-time choices. How am I going to slice my network? When am I going to share the spectrum? How am I going to decide what is the right bandwidth to allocate to which user? How am I going to do traffic prediction so that I can get the right latency requirements for the different use cases? So these are the examples where the 5G network very much depends on the power of AI to make the networks, so much more, smarter. So I think that's why we are at this, nice symbiosis point where these two technologies really need each other so that they can actually further their own agenda and in terms of what promise they can deliver.
Yeah, definitely. Is there anyone
Can I
else
add
like Elena?
something?
Yes,
Yes,
please
I
do.
would like to add something. I totally agree with what has been said. I think it's the need, the actual need that meets the opportunities and the technology that has been developed to this point. And then another interesting factor is that we need to go after optimize the resource utilization. And here is why we need to have this concept of network slicing, many different industries using the same network in a smart way. We need to think sustainability. And these are like perfect scenarios or perfect use cases and trade-offs when you need to apply these multi-objective optimization methods and many different AI methods for the network to actually to make sure that from the same amount of equipment we are delivering the best service possible and the most sustainable service possible. So that's the convergence of the need on one side and the opportunities with technologies on the other side.
Yeah, I love that. I think that it's that, oh, go ahead, Sanyogita.
Yeah, no. So to again kind of summarize what both Elena and Vanita said, tools such as AI and ML are almost necessary when you're operating a complex network that we have today. There is a combination of 4G as well that we need to manage, 4G, 5G network. So as I look at it, these are tools that we use not only for like the back of the house, which means the running and the operation of the network, which is somewhat transparent to you and me. And then the front of the house with applications and services which use all these tools like the stuff that Sophia, your company does, right? Snap. It's customer facing. It's the stuff that and you also use these tools, right? So it's kind of it's something that essentially is used in front and back of the house is how I like to think about it. If you want to think about it simply, so there's a wide variety of applications and services possible.
Yeah, I love that. And kind of leads me to my next question, which is how do we think that artificial intelligence can drive the creation of new services within verticals that exist today, such as health and mobility, or ones that we haven't even thought of?
Yeah, let me take a stab at that, and then maybe some of my colleagues can add. So today we are talking about healthcare, right? Telehealth all of a sudden has accelerated because of COVID, and we are going to the doctors, on a Zoom call or a WebEx call and so on, or even FaceTime. And in applications such as that, to be able to have, let's say, a diagnosis that can that may be more automated is a possibility, like a skin condition, right? Maybe we don't have the best cameras on some of our tools, but having things that are trained on different types of cameras, like different types of skin issues trained on different types of cameras, and using machine intelligence to be able to diagnose some of those can help aid the diagnosis of such conditions. And of course, a very good doctor in person will absolutely be able to diagnose it much better. But it can be a very great first step, a very good first step to a more qualified doctor, perhaps. You're also talking about if you talk about learning, education, right? Remote learning, it's not easy. It's difficult. And today's technologies, when you look at what is available, for example, for an educator, what we have done is really made it, instead of personalized education for each student, what we have done is, how do I make grading easy, right? Online bubble charts and making, I think most of the technology development has been focused on mass scales rather than individualized learning. I think we can talk about using some of the AI and ML tools to create individualized curriculum for each student, and the fact that we are able to deliver in a remote fashion can really help accelerate that particular way of delivering education. Now I can maybe something pops up on the screen when a particular student comes into the window and say, hey, this particular student has these, probably challenges in this particular area. So maybe the teacher needs to adjust the curriculum according to that, and so on and so forth. So you can, those are just a couple of examples that you can talk about. But there are, think about it, hundreds of different applications and use cases when you talk about services.
And I think another important, I think a very significant area, I think where we are going to see a lot of new applications coming up is actually also smart cities, right? When I'm talking about smart cities, I'm actually talking about safety, sanitation, as well as energy efficiency, right? These are all very big elements, and all of these things, if you think about it, right? If you're when we usually talk about smart cities and autonomous cars, right? We actually think about vehicle to vehicle communication, but that's only one dimension of what we are focusing on today. But actually, the more advanced versions of this is basically, we call it vehicle to infrastructure communication. How do vehicles communicate smartly to the traffic lights, and and traffic lights is actually another great example of the distributed intelligence, right? It's no more the cloud, not the vehicle, but these are use cases where an entity in the middle needs to actually collate data from many different sources and make smart decisions, right? Whether it is about maybe changing the patterns of the traffic lights based or accident detection, and how do you get that communicated to everyone else. And also the vehicle to pedestrian communication. So we talk about many different entities here, right? The vehicles, the pedestrians, the infrastructure, and how do they all kind of collaborate together to make intelligent, decisions for traffic control, congestion control, that aspect of it. And then this whole aspect of the energy efficiency, right? How do we collect the data from many different devices to make smart choices on our energy grid, whether it's controlling night lamps or traffic lights or the street lights, I should say. And also the same thing with sanitation, water quality, right? How is that affected in terms of agriculture, right? How do you monitor various different things, whether it is from the soil or whether it's from the water, and how, more importantly, how do you kind of take all this information back, consolidate that, and make a decision not deep in the cloud somewhere, but at some kind of a distributed level where the turnaround time can be very efficient.
So yes, I would just summarize that, in the past, wireless networks have been focused on human communication and human video consumption and internet. I think as now robots and drones and, these industrial devices get connected to the network, 5G will allow you to have, ultra reliable, low latency links that will enable you to develop new services. Think about unwiring the factory or unwiring, today's hospitals, which have, if you look at the hospital, visuals, there's all these machines are connected to so many wires. So we expect that, going beyond human consumption, 5G will enable control applications in industry, as well as distributing compute. So for example, if your device cannot handle the computational complexity of a task, such as a gaming task, you could distribute it to the edge or to the cloud, and 5G will enable that through the high-speed, low-latency transfers. So we see a convergence of communication, again, as I mentioned, and computing going forward.
Yeah, cloud gaming is a great example, another great example, right? Today we have console-based gaming that is very high resolution, high quality, and so on. And usually the mobile-based games are simpler, turn-based, right? When you talk about taking some of the console quality gaming to mobiles, you require a console quality compute available to you at a latency that you can play real time games. So I think from an entertainment viewpoint, that's one of the early examples that you will start seeing from a consumer viewpoint.
Yeah, that's something that we think a lot about at Snap, especially as we're trying to deliver higher quality lenses and augmented reality experiences. So incredibly important. I'm going to take some of what Sanyogita said about, especially today with COVID, and kind of to frame 5G today. So how did COVID-19's effects on social isolation affect consumers' desire for video streaming, AR, VR like technologies, gaming, and how has the rollout of 5G assisted people in social isolation?
Shilpa, you want to start? Okay.
Yes. I want to sort of, talk about a technology we've been developing in Intel Labs. It's not commercial yet. It's in proof of concept stage, but it's basically multi-com. The idea is to be able to seamlessly, communicate between LTE, 5G, Wi-Fi, or any other network. So, for example, if you're in a video conference and your Wi-Fi link dies, the packets should be, seamlessly and automatically routed through your 5G or LTE link. And so enabling this technology and the intelligence and, making sure that the transmissions are reliable, that you always see, a certain minimum level of throughput all the time is important, because I found myself these days, when I'm on an important call, I'm not only on Wi-Fi, but I also dial in it to my 5G or cellular network to make sure that I'm always on. So, yeah.
Actually, another big shift that I see is definitely people taking like a lot of their calls when they're out on their walks and everything, because that's something that I see that happening, because people are stuck at home like throughout the day. So when in fact a lot of my teams actually do like walk and talk meetings actually. So and that's really not something that is even possible unless you have like a very good broadband technology on your phone. So and now if you kind of extend that to like walk on talk with video on, and walk on talk, like think about international with voice translation built in there. So you can imagine you can just keep piling the services on top of it, and all of this, which would have been nice to have a few months ago, now just seems like something, God, how do we live without these things? Because I think that's something that this unfortunate COVID situation has shown us, like the power of connectivity, right? Like how did we just with the flip of a button go from all of us interacting on a daily basis, whether it's with our doctor or the student teachers or with our colleagues, how did we suddenly, like, we are still able to do everything that we were doing, our productivity is still so high. And all of that is really because of the connectivity in our hands these days. So, I think that's made the power of these technologies, I would say, even more obvious.
Yeah,
Elena, I know you had a point to make. Why don't you go ahead? And then, okay.
Yeah, so I just want to say, wireless has been sort of fundamental technology, very important during these COVID times to keep us connected. It's just amazing how the networks have kept up with the high demand that's required at this moment. Okay, sorry. Go ahead.
No, I was just going to add something to this discussion that I think it's fantastic. I agree how much we are nowadays using video and how much we are using AR, VR. We do look into technologies such as Internet of Senses, where one can actually send like sensations, maybe a taste. And then I think what's another fascinating thing is the brain-computer interfaces that is kind of a novel thing that's growing nowadays. Research in that thing, when you kind of can control things with your brain, when you can wear an exoskeleton, or maybe you can control something on a distance, which is almost reality now, which really requires a very reliable and high-speed network. So that's absolutely new era, I think, of interfaces compared to like what we had before.
Yeah, that two examples that I want to give during COVID that immediately show you the power of what connectivity and video is needed, right? So my team has the interesting task of bringing a lot of these technologies together, like I said, and you would maybe 6 months ago virtual reality was like, okay, whatever, right? I mean, maybe augmented reality is like maybe more for gamers. I'm not it's not necessarily my thing. Probably not the right audience, right viewpoint for this audience, but nevertheless, at Indy 500, which is like a racing, car racing event here, they decided that they're going to have the event and not get any fans inside. They get 300,000 plus fans in the stadium, and due to COVID, they were not going to bring anybody in. But at the same time, people wanted to experience that remotely. So what we did is we deployed like 360-degree cameras on a 5G network on the tracks, and we were able to give the experience of being like on the track or close to the track using AR type of applications on a 5G device. That wouldn't have been possible, let's say, in the 4G days, because the bandwidth required for something like that is significantly high. And then the other thing is like now sports is kind of people are not going into stadiums, and so we're talking about doing a lot of stuff remotely and experiencing and enjoying sports. So more recently, what Yahoo Sports did was watch together. So you can watch with 4 or 5 of your friends a game in real time, so that you're not dialing into 5 different things, right? And you can do that on your phone. So that is limited right now to 4 or 5. If you have the bandwidth and if you have the capabilities of 5G, you could envision having more friends online and higher quality videos online, so that you can experience that as if doesn't replace completely that you're not in the stadium, but you could have a lot more of that experience remotely. So from an entertainment viewpoint, you see that these are some applications that are already emerging that maybe the post-COVID world will see use for.
Yeah, and I think going off of the sports example, for what it's worth, I am not really a sports fan, but I do find the technology very interesting. Like Intel and Shilpa, maybe you have more insight into this, like the True View, which will be launching pretty soon, which will enable you to see different views, I believe, of the football field and or like other sorts of sports. Yeah, if you can talk a little bit about that, if you have any information, I think could be valuable for like future initiatives.
Yeah, so sorry, I don't have more information than you. I'm not. Yes, go ahead.
I can chime in. I know a little bit about that. So the Intel's TrueView technology is basically, deployed in, some of the stadiums where there are like, 100 or so cameras surrounding the stadium. And this is a new type of technology called volumetric, where you are actually kind of being able to see the game from any which angle, right? Because you have all the camera angles. That generates a lot of data, and you really also need to process that in real time if you want to watch it in near real time. Today, it's still like kind of delayed post-process because it requires a lot of compute, but you can envision a day when, maybe not too far in the future, where you can see this, let's say with a lag of like just that broadcast, which is like, 7-8 seconds, that you'll be able to experience, and then you can watch from one angle while the person sitting next to you can watch from another angle. All this is made possible because first of all, you have the bandwidth to gather this video, as well as intelligence and training to train your algorithms so that you can create those different views in near real time. So it's a great example of being able to use a lot of ML actually in this, as well as computer vision and data image processing and everything else in this whole processing chain.
Great. So that'll lead to our last question, which is kind of an open-ended question, which is, what do you believe is the most promising area where 5G will have the most influence for students and or companies? Where do each of you see the biggest opportunities?
So,
All right.
well,
So,
sorry, go ahead, Shilpa.
okay, yeah, I just wanted to talk about the NSF research program that we have, and we are working with many universities, 20 plus universities in the U.S. To determine which are the key areas where machine learning and AI can help in wireless. And we've identified three areas ourselves. One is management of the networks, so optimizing the networks because they're becoming more complex with AI techniques. The second area is spectrum access, so using AI and machine learning to improve spectrum access so that you don't have as much contention as we do today. So we're able to predict what the other machines are doing, and being able to use spectrum more respectfully and fairly. And the third area is distributed intelligence, basically distributing the intelligence AI processing between the device, the edge, and the cloud, and managing the services across these entities as they're one single entity. So those are some of the areas we've looked at, but I think this is an emerging area, and there's a lot of potential for new research.
Great, Vanitha.
So what I wanted to say was like I think we all have our pet applications and pet areas where like our own version of, hey, this would be so cool, and I can totally see that being enabled by the power of AI combined with 5G. For example, a field that's of personal interest to me is definitely the telehealth area. I think this is going to be like just like how Sanyogita was talking about things that we want to stay on even past the post-COVID phase is basically the telehealth, right? Because there is a lot of socio-economic, impact to the telehealth, because people that have to take, like right now, if somebody has to travel to take a doctor appointment, if they cannot really afford that's like a half a day off, like half a day of pay loss for them, right? But that is something definitely the telehealth can avoid. Like it just really cuts down all the time to like a few minutes to maybe at most an hour. But beyond all of this, I look at like 5G as pretty much like when we first got the personal computers or the internet, right? It's not about which will be the area that will be most impacted by this. I think it's actually the question the other way around. If anybody in any industry should be basically looking at it in terms of how am I going to make use of 5G and make my life better, make some kind of innovation to what I'm doing, because that is actually the kind of impact and reach the combination of these technologies are really capable of having. Like from we covered like smart cities, agriculture, healthcare, robotics, immersive experiences. There is really no end. That's just some of the things we can think of, right? So I think we really think that we want a lot of the innovators and the inventors to kind of get on this bandwagon and think about, hey, how am I going to make use of these technologies?
Great, Elena.
Yeah, so I think I'll give a couple of angles to this. I think any data-heavy industry that requires execution, any data-heavy industry will benefit a lot of 5G plus AI in combination, because processing a lot of data requires AI. 5G is required to be able to move around the execution and to the edge, as we discussed here, the convergence of compute and network. Then I think this thing with, what we see in education is that how AI starts populating different kind of fields of education, right? Before, when I studied AI, it was like 20 years ago, and it was part of computer science program, that's it. But now it's actually, it made it to all different programs. It's part of healthcare, education, it's part of even architecture, all different, which is fantastic, because it really helps. We need to learn how to apply it and how to use it as a tool. And that will lead us to a lot of innovations, of course. And then the third angle, I would love to see the impact of 5G and AI on sustainability and climate action.
And Senorita?
Yeah, I think my colleagues have done a great job talking about, how powerful, some of these capabilities are and what will they bring. I do think that we are at a point where, like Elena says, data is everywhere. Every single field has data. I mean, my daughter is in computational biology, and all they do is a lot of data analysis and, accelerate trials and so on and so forth. So from if you look at that, you can basically take any field that you are in and any area that you're interested in and think about how you can use the connectivity and the capability that the cloud and connectivity bring together to solve your problem. So without constraints, think broad, think big, and see what you can build, because you now finally have the tools to do that. That's all I can say. I think the world is at your beck and call at this time.
Well, it's a great way to end this panel. Thank you all so much for your time. And with that, we'll take questions.